In this video, I'm going to go over with you the three common trig derivatives that you'll need for the AP test. There are other trig derivatives, but you know we won't use those as much. A lot of the other ones like cosecant, secant, and cotangent will be used probably in a calculator active problem. But these for sure you would have to have memorized. And let's start out with the sine. So let's say we had y equals sine x. And let's take a look. Let's graph the derivative of the sine. So let's say y equals, and then let's go derivative, calculus, derivative, and then let's put in sine x. And if you notice on here, our black curve is the sine. We're going from 0 all the way to 2 pi. And then the blue graph would be the derivative of the sine. And if you notice that blue graph, that is just the cosine curve. So what we have is that the derivative of the sine is actually equal to the cosine. Okay? All right, let's take a look at the cosine. So now the black curve is the cosine. And then let's graph the derivative of the cosine. And we can see now the blue graph is the derivative of the cosine, and we can see that it is the sine curve with a reflection. So the derivative of the cosine is equal to the opposite of the sine of x, or negative sine x. All right, so that's always a good demonstration to show the students on the derivatives, and we just memorize these. And one key thing is that any co-derivative is going to be negative. So cosine, cosecant, when we learn cosecant and cotangent, their derivatives are negative. Okay? So we like to demonstrate these on the calculator just to see the relationship. All right, so we showed on desmos that the derivative of sine x comes out equal to cosine x, and the derivative of cosine x is equal to negative sine x. And another one we have would be the derivative of tangent x is equal to secant squared x. All right, so these three are the most common ones in the non-calculator that you're going to use on the AP test. All right, so let's do some examples with this, and then all rules apply from the basic rules of differentiation, your constant multiple rule, and your sum or difference rule. So, for example, if we had y equals 19 cosine x plus 11 sine x. Okay, so just working our way across, y prime would be, now the derivative of the cosine, every time we hear co with the derivative, it's going to be negative, so cosine x is equal to negative sine x. That's a good way to remember which one's negative. So this would be negative 19 sine x plus the derivative of sine is cosine. We have the constant multiple rule. So this would be plus 11 cosine x. Okay. So let's say that we had something like this. Let's do something with the tangent. So let's say we had f of x is equal to 3 tangent x minus cosine x, and we want f prime. Okay, so we would say f prime x is equal to the derivative of tangent is secant squared, and we have the constant multiple rule, so this would be 3 secant squared x minus cosine x is negative sine x, so we would get 3 secant squared x, and we have a minus times a minus, so plus sine x. Okay? Now, one thing you may run into is something like this, um, especially before we do chain rule, product rule. Um, if you get something where we had this, well, first off, at this point with the basic differentiation rules, we haven't learned chain rule yet. And we can see that we have squared here. Well, you can always use your trig derivative or your trig identities to simplify things. So we remember from trig that secant squared x plus cosine squared x equals 1 from the Pythagorean identities. So this problem is the same as y equals 1, so y prime would actually be the derivative of a constant, which is 0. Okay? All right, so basic differentiation rules, these are the 3 non-calculator trig, and we'll start practicing these, and then we'll use them later as we learn more rules: product rule, quotient rule, chain rule. Okay, thanks for watching.